Hello everyone, this is J. Kalpana here. In this video, we're going to see a problem from partial differential equations by eliminating the arbitrary constants. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from x square plus y square equal to z minus c whole square into tan square alpha. So we are asked to eliminate constants to form partial differential equation from the given equation. We are given an equation x square plus y square equal to z minus c whole square into tan square alpha, right? Here z is a function of x and y, okay, and x and y are independent variables. So consider the given differential equation as equation 1. Now partially differentiating 1 with respect to x, okay. So apply dou by dou x on both sides of the equation. Firstly, I'll explain in detail and next we'll see the shortcut, okay. It's alpha. Since we are partially differentiating with respect to x, so y will be treated as constant. We can write this as dou by dou x of x square plus dou by dou x of y square equal to, it is a constant, right, complete constant, that is tan square alpha into dou by dou x of z minus c whole square. Since c is constant but z is a function of x and y, so we'll write it like this, right? And this gives us partial derivative of x square with respect to x is 2x plus partial derivative of y square with respect to x is 0, because y square is treated as constant since we are partially differentiating with respect to x, equal to tan square alpha into partial derivative of z minus c whole square is with respect to x is 2 times z minus c into partial derivative, that is inner derivative of z minus c whole square, that is partial derivative of z minus c, right? This gives us 2x equal to tan square alpha into 2 times z minus c into dou z by dou x, that is partial derivative of z with respect to x minus partial derivative of constant with respect to x, okay. This gives us 2x equal to tan square alpha into 2 times z minus c into partial derivative of z with respect to x is dou z by dou x minus partial derivative of a constant with respect to x is 0, which gives us 2x equal to tan square alpha into 2 times z minus c into, you can replace dou z by dou x using the notation dou z by dou x equal to p. We'll get p here, okay. So which gives us 2 times z minus c into p into tan square alpha. 2 gets cancelled and you can write this as just bring this p tan square alpha to LHS, you'll get x by p tan square alpha equal to z minus c. Consider it as equation number 2, right? Now partially differentiating 1 with respect to y. Now we'll partially differentiate 1 with respect to y. So apply dou by dou y on both sides of the equation. Since we are partially differentiating with respect to y, so we'll treat x as constant here. Right? You can write this as dou by dou y of first term plus dou by dou y of second term equal to dou by dou y of, we can write this as some constant, that is tan square alpha into partial derivative of z minus c whole square with respect to y. Here c is constant and z is a function of x and y. Okay, fine. This gives us partial derivative of a constant with respect to y is 0. Since we are partially differentiating one with respect to y, so we'll treat x as constant. Okay, while partially differentiating something with respect to y, we'll treat x as constant. We know that. So you'll get 0 plus partial derivative of y square with respect to y is 2y equal to tan square alpha into partial derivative of z minus c whole square with respect to y is 2 times z minus c into inner derivative, that is partial derivative of z minus c. Right? This gives us 2y equal to tan square alpha into 2 times z minus c into partial derivative of z with respect to y minus partial, can just write this as, okay, minus partial derivative of constant with respect to y. This gives us 2y equal to tan square alpha into 2 times z minus c into partial derivative of z with respect to y minus partial derivative of a constant with respect to y is 0. Since we have a notation dou z by dou y equal to q, so we'll replace it by q. Now this gives us 2y equal to tan square alpha into 2 times z minus c into replace dou z by dou y by q, you'll get, right? We can write this as 2y equal to 2 times z minus c into q into tan square alpha. Cancel this 2 and bring this q times or q into tan square alpha to LHS, you'll get y by q into tan square alpha equal to z minus c. Okay, consider as equation 3. Now observe 1, 2 and 3. By observing 2 and 3, we notice that z minus c equal to x by p tan square alpha and z minus c equal to y by 2 tan square alpha, right? So from 2 and 3, if we have any 1, we can just replace that 1. Okay? You can just, if you have any 1, we'll just replace this z minus c by that 1. And there the tan square alpha gets cancelled and also c gets eliminated. Okay, but in our case we have two things which has z minus c equal to some expression. So what we'll do is we'll equate these two. Then we'll get x by p tan square alpha equal to y by q tan square alpha, where tan square alpha gets eliminated. Then x by p equal to y by q. Now make a cross multiplication, we'll get qx equal to py or xq equal to yp. Okay, or we can write this as py equal to qx, right? Which is an equation which does not involve any arbitrary constants, right? So therefore py equal to qx is the required partial differential equation. Okay, or this is an equation of the form, say okay, fine. Now let's see the same problem by reducing the number of steps. Given x square plus y square equal to z minus c whole square tan square alpha, right? So partially differentiating 1, we'll consider some equation 1. Partially differentiating 1 with respect to x, you'll get 2x plus partial derivative of y square with respect to x is 0, since we are doing partial differentiation with respect to x, so we'll treat y as constant. So you'll get partial derivative of y square with respect to y, with respect to x, which is 0, is equal to partial derivative of z minus c tan square alpha is a constant, just write tan square alpha into partial derivative of z minus c whole square gives 2 times z minus c into inner derivative, that is inner derivative of z minus c. Derivative of z with respect to x is 1. Okay, dou z by dou x minus partial derivative of constant with respect to x is 0. You'll get 0 into 0, right? This gives us 2x equal to tan square alpha into 2 times z minus c into, use the notation dou z by dou x equal to p, just replace it by p, you'll get into p, since dou z by dou x equal to p, right? Where 2 gets cancelled, or you can just write one more step, 2x equal to 2 times z minus c p into tan square alpha, right? 2 gets cancelled. Now bring p tan square alpha to LHS, you'll get x by p tan square alpha equal to z minus c. Consider as equation number 2. Now partially differentiate 1 with respect to y. Since we are partially differentiating 1 with respect to y, so we'll treat x as constant. So partial derivative of x square with respect to y is 0 plus partial derivative of y square with respect to y is 2y equal to constant tan square alpha into partial derivative of z minus c whole square with respect to y is 2 times z minus c into inner derivative, partial derivative of z minus c gives dou z by dou y minus partial derivative of c with respect to y 0, right? Which gives us 2y equal to 2 times z minus c into, replace dou z by dou y by q, since we have a notation, right? So I'll get into q into this tan square alpha, where 2 gets cancelled. Now bring this q tan square alpha to LHS, you'll get y by q tan square alpha equal to z minus c. Now consider as equation number 3. See, you got the same thing. Okay. See, if you have either 2 or 3, you can just apply 1. Okay. If you have 2, you can just apply or replace z minus c by 2. And if you have just 3, you can just replace z minus c by this. But here we have 2. Z minus c equal to x by p tan square alpha and z minus c equal to y by 2 tan square alpha. Okay. So what we'll do is we'll just equate these two. From 2 and 3, we get x by p tan square alpha equal to y by q tan square alpha, where tan square alpha gets cancelled, and this gives us q by p equal to y by q, x by p equal to y by q. Now make a cross multiplication, we'll get qx equal to py or py equal to qx or yp equal to xq or xq equal to yp. Okay, which is a required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.